Okay, so where we left last class was talking about related rates. We covered this problem and we kind of paused and said, all right, let's talk about this next class. Give us a little time to process. So what happened? What we have in this last problem is a ladder against a wall. We have the distance of the ladder, we have the distance to the wall, and we have the distance up the wall. But then the ladder slips. So yes, we have length, length, length. We have a right triangle, but the ladder's slipping and the bottom is falling out and the top is falling down. And that's causing the rate of change. So how fast is this ladder going down? How fast is this ladder going out? So not only do we have distances, but we have rates at the same time. So this is where the problems are starting to mix a little bit. And what we did was we started with equation number one. We remembered, hey, it's a right triangle, which means we can use Pythagorean theorem. A squared plus B squared equals C squared. Remember, A and B are always the legs, we call them, and the long side is the hypotenuse. And then we figured that out, but that's only one equation. To get the second equation, we took the derivative of that. So the derivative of x squared is 2x, but we took the derivative of it. So that's why you have that dx over dt. We took the derivative of x with respect to t. Then we took the derivative of y squared, which is 2y, derivative of y over t because it's over time. It's a rate of change. And the derivative of 676 is 0. I would have put d something, but it's 0. Anything times 0 is 0. So we had 1, 2 equations, and then we were given a bunch of information. We're given the ladder, the distance of x, but we weren't given y. We're given the rate of change of y downward, negative, but we weren't given the rate of change of x. So then we have to do all the work, and it's kind of like a little game, and then we're going to practice. Okay, so hopefully we looked at it. Hopefully it kind of makes sense. We're going to do one very similar, but a different scenario. Very similar, but a different scenario. Now, I'm going to give you a lot of setup to get started. I'm going to give you a lot of setup to get started. So it's not just you kind of doing these all on your own. You'll have a little bit of help. You'll have a little bit of help, a little bit of setup. Okay. So this one says, suppose at the moment a westbound plane traveling 120 knots is 120 nautical miles from an airport. So first of all, knots is a rate of change, like miles per hour, but for a plane, it's knots. And then 120 nautical miles, that's a distance from the airport. A northbound plane, so this is the westbound plane, this is the northbound plane, is traveling 160 knots, passes directly over the airport. This is the airport. Refer to the drawing. How fast is the distance between the planes changing 1/2 hour later and all that kind of stuff? So let's just start out with what's given. And I'm going to give you a little bit more kind of than that's what's there. But we have the northbound plane. We have the westbound. And we have, so let's call this W. That's the westbound train. Oh, plane. And let's call this distance N for north. Okay. Then we're going to have this hypotenuse. Let's call that D. Okay. Now, of these three, let's say it was given that the northbound is 80 nautical miles away. Now, it's not given in the paragraph, but it's given a little bit below. The westbound plane is 60 miles. 60 miles. And again, it's given below. It's given below. Just kind of showing you. But we don't have D. Okay? So the north is given 80 miles. The west is given 60 miles, but we don't know the distance of D. We don't know the distance of D. Where did the 80 and 60 come? It's below. It's given to us below. It's given to us below. It's not given to us in the first paragraph. Okay? Then we have all these speeds going on. So we have dN over dt, dw over dt, and dd over dt. So not only do we have three distances, we have three speeds. And again, what's given and what's not given. So they told us that the northbound is going 160 knots. So 160 knots. Now, I would help you out a little bit here, but because it's going away from the airport, that's positive, positive. The westbound, oops, I put it in the wrong place, sorry. Northbound is 160. Northbound is 160, sorry. Northbound is 160. 160. The westbound is 120. But because the westbound is going towards the airport, that's negative 120. And I don't know the speed change for D. Okay, so stop there for a second. Let's say all of that was given to you and it was very clear. Let's say all of that, it's not written in the paragraph, it's not written in the paragraph, it's not written in the paragraph. It is given to you now, it is given to you now, it's given to you now. Okay, so let's say all that's given to you, all that's given to you. Then we have two things we don't know. We don't know D and we don't know dd over dt. So we don't know those two things. But we find that this is a right triangle. So what I'd like you to do, based on the last class, I know it's a little bit of a jump, but just giving you a little time to think about it, see if you can come up with the two equations that are needed to solve this problem. See if you can come up with the two equations that are needed to solve this problem. So the question is, what are the two equations? Well, let's go back and look at the old one. The last example we did, we noticed that it was a right triangle. So we did x squared plus y squared equals, in this case, z, or the hypotenuse squared. That's what I'm going to do here. Same thing, same thing. I'm going to do, it doesn't matter the order, but I'm going to have n squared plus w squared equals d squared. Now, if you're writing that down as fast as possible, what happened, right? We got to be able to practice, got to be able to learn from the previous example. And I'm really worried about blanks, right? This is, if this was a 10-point problem, you wouldn't be able to start it, right? And it's just like the last one. Now, here's where things are a little different, and maybe you made a mistake, but it doesn't matter. It's the trying. The next one is taking the derivative. So, and again, let's look back at the old example. At the old example, we took the derivative of x squared. We had 2x dx over dt, derivative of y squared, 2y dy over dt, and the derivative of a number is 0. So using that to learn from, what is the derivative of n squared? That's 2n dn over dt, plus the derivative of w squared is 2y derivative of w over dt equals. Now, this is where it was a little different from last time. Last time we had a number. This time we don't have a number. So what's the derivative of d squared? 2d dd over dt. So here's equation 1, and here's equation 2. So if we made a little mistake, no worries, just fix it. But if it's blank and you're waiting for me to hand it to you, that's where I have a problem, okay? Now, notice I have all the elements, all the pieces that I need now. So for example, I have n, perfect. I have w, perfect, but I don't have d. I can use the first equation to find d. Once I have n, w, and d, then I can use the second equation, because I got everything plugged in, to find dd over dt. So your goal right now, like a little game, is to find these two, given these two equations. And I've already kind of given you a step 1, step 2. Step 1, use the first equation to find d. Step 2, use the second equation to find dd over dt. So if you're kind of wondering, do I go for the D first or the dd over dt? You have to go for the D first, because if I try to go to the second equation, I can't use it because I don't know D and I don't know dd over dt. So you have to find D first. There's no choice. right? You have to. I need D to find d dt. So I use the first equation, n squared plus w squared equals d squared. I know n is 80. 80 squared plus w is 60 squared equals d squared. Now, 80 squared is 3,600 plus 80 squared is 6,400. That equals 10,000 equals d squared. But keep in mind, I'm not looking for d squared, I'm looking for d. So I'm going to square root both sides, square root both sides. Technically, you get positive or negative 100, but since we're talking about a distance, d is 100. So we find that d is 100 nautical miles. D is 100 nautical miles. So I use the first equation to find d. So now for the next one, we can use the second equation. So now I'm going to plug in everything that I know and solve for what I don't know. So n is 80. dn over dt is 160. Plus 2 times w is 60. dw over dt is negative 120. Now, again, that negative can really cause us trouble, but I'll make sure that you know it's negative. 2, I know a d is now 100, d over dt. It's a little cramped in there, so I'll make it a little bit larger. Okay, so now I can start solving this. If I multiply the first 3, that gives you 25,600. If I multiply the next part, that gives you negative 14,400 equals 200 dd over dt. If I combine those, that gives you 11,200 equals 200 dd over dt. Divide by 200, divide by 200, and we get dd over dt equals 56, and it would be 56 knots. Okay, so take a minute, make sure that all makes sense, make sure you got the same numbers, all of that. And then let's kind of pause and figure out what happened. What are we actually finding? What's going on in this problem? Okay, so we know that dd over dt is 56 knots. So if I was going to explain all this, how would I explain all this? Well, the airport is located right here, and the distance from the westbound to the airport is 60 miles away. That distance is 60 miles, plane to airport. The northbound, here's where the plane is, that plane is 80 miles away, 80 miles from the airport, and the distance between the two planes at that moment is 100 miles. Okay, what else do I know? I know that the westbound plane is going negative 120. Again, negative because it's going towards the airport, 120 knots. The northbound is going away from the airport at 160 knots. And the distance between them, how is that changing? How is that changing? 56 knots. 56 knots. Okay, take a minute, see if it makes sense. So the first 2 examples we did, those are more of the classic related rates problems. This one is also related rates, but let's say it's a little different, a little different than the classic. Okay, so here it says, suppose a point is moving around a circular path centered at the origin and radius 5. So here's this point, and this point is going around the circle, around and around and around. Okay, and it says with a radius of 5, radius of 5. You can see that it's a radius of 5. Radius is the distance of the center to the outside of a circle. Okay, and the graph has an equation, x squared plus y squared equals 25. Okay, that's the equation of a circle. That's the equation of a circle. When the point is located at a very specific point, negative 3, 4, we know that it's increasing at a rate of 0.4 units per second. And what is increasing? The X coordinate. The X coordinate is increasing, okay? Now, how do I take this and make it like we did before? Well, you are given a point, and that point is -3, 4. And if you remember points, what's the first number, X or Y? X. And the second one is, so we know that X is -3, and we know that Y is 4. Now, in the problem, they just told us the rate of change of X. The rate of change of X is increasing, which means positive, 0.4 units per second. And the question is asking, what is the rate of change of Y? That is dy over dt. That's the one thing we don't know. So they gave us the first equation. Your job is to figure out the unknown. And the unknown in this case is dy over dt. We know how X is changing, but we don't know how Y is changing as it goes around that circle. So give it a try. So what was given to you was X is -3, Y is 4, dx over dt was 0.4 units per second, and we don't know how Y is changing. We don't know dy over dt. So we have the first equation, but now we need the second equation. So the derivative of x squared is 2x dx over dt. The derivative of y squared is 2y dy over dt. And the derivative of 25 is 0. Anything times 0 is 0, so we're left with just that. Now, we don't even need the first equation because there's nothing here. There's no x, y, and z or something. So we don't even need the second equation. The first equation. All we need is the second equation. So we're going to use the second equation because I already have everything I need. So 2 times x is -3, dx over dt is 0.4, plus 2 times y is 4. I have everything except dy over dt. So this one actually, we can skip that first part because there is no z or other variable to solve for. I can go straight to the second equation. And if we do that, you get -2.4 plus 8 dy over dt equals 0. Then it's just algebra. Add 2.4, add 2.4, 8 dy over dt equals 2.4, divide by 8, and we find that what is the rate of change of y? How fast is y going? It's going 0.3 units per second. We find that dy over dt is 0.3 units per second. Okay. So since you want a few business applications of this, we're going to do a couple business applications of this, okay? So this one says, suppose a company manufactures flash drives. So to be very clear, X is number of flash drives. Remember, flash drives, I don't know if people even use them anymore. They're ways to kind of share information, store it on a little thing, and then share it. A lot of people do it on the cloud now. Some people don't trust the cloud, whatever it is, but flash drives are a way to kind of share information, handing someone a flash drive, okay? And you figure out that your cost equation is 5,000 plus 2x. Your revenue equation is 10x minus 0.001x squared, and we know that profit equals revenue minus cost. Well, you're given some information here, and the information you're given is the rate of change, related rates, rate of change. So it tells you where the production of 1 week is X flash drives. So we know that X is number of flash drives. Okay, they tell you if production increases to a rate of 500 flash drives per week. So first of all, is that number of flash drives, or is that how the flash drives are changing? So that is dx over dt. Why? It's a rate of change. It's how x is changing. And this would be 500, and we'll put FD per week. FD is flash drives. Okay, so they're giving you a rate. So that's why it's going to be a little different. And then they tell you that the production is 2,000 flash drives. So X is 2,000 flash drives. Now, in this case, we're talking about cost. And I want to know how the cost is changing. How the cost is changing. So you start with the cost equation, 5,000 plus 2x. Now, that is a great equation if I want cost. That's a great equation if I want cost. But what do I want to know? I don't want cost. I want the rate of change of cost. So I have a rate of change. I have x, but this is plain old cost. So this is where it gets a little weird. We're going to take the derivative, the rate of change of cost, with respect to time to get that rate of change in there. So nice and slowly, what's the derivative of 5,000? 0. Anything times 0 is 0. That part's gone. What's the derivative of 2x? 2, but what'd you just take a derivative of? You just took the derivative of x with respect to time. Now that's weird. That's weird. I get it. But this becomes my rate of change, how x is changing. 0 plus anything is just the number, right? We get 2 dx over dt. Once I get that equation, now you can plug in. So what's the rate of change at 2,000 flash drives? You take 2 times dx over dt. What's dx over dt? 500. So what is the rate of change of those 2,000 flash drives? 2 times 500, that would be $1,000 per week. $1,000. This is 1,000. That's a cost per week. So if I was going to write this in a sentence, if I was going to write this in a sentence, at 2,000 flash drives, the cost is increasing $1,000 per week. Take a minute, let that soak in a little bit, how we did it. Okay, so here's the next one. We're going to do the same thing. Now I want to know if the production increases at a rate of 500 flash drives per week. So we know, again, that dx over dt is 500 flash drives per week. That is given to us. Again, what's given to us? X is 2,000. Now I want to find the rate of increase for revenue. How is revenue changing? And if you look earlier, revenue is given. Revenue is given 10x minus 0.001x squared. So I'm going to give you the revenue, and I'm going to see how you do. So revenue is 10x minus 0.001x squared. And the question is, what's the rate of change for revenue per week? What's the rate of change for revenue per week? Okay, since we're dealing with rate, we want to take the derivative. And when we take the derivative, we want to make sure we include the rate. Now, be careful, be careful. The derivative of 10x is 10, derivative of x with respect to t, minus the derivative of 0.001 x squared, 0.002 x dx over dt. So again, pause. Did you get the first dx over dt? Did you remember the second dx over dt? And there's an x in there. There's an x in there. So it's all about the details, the details, the details. 10x is 10, it's not 0. So we don't put 0 and then there's nothing else. You have to have the dx over dt, like we've done earlier. And then this one we have a little extra. And now, like you asked earlier, if you plug in 2000, dx over dt is 500, minus 0.002, x is 2000, dx over dt is 500. Okay, so be careful, be careful, be careful. If you plug all that in, you will get 10 times 500, which is 5,000, minus multiply all of those, you'll get 2,000, and that will give you $3,000. So in a sentence, at 2,000 flash drives, the revenue is increasing $3,000 per week. Okay, at 2,000 flash drives, the revenue is increasing $3,000 per week. We're going to do one more. So we did cost, we did revenue. Which one haven't we done yet? So let's do profit. And the reason why I'm going to make you happy here is we know dx over dt is 500 flash drives per week. We know that x is 2,000. But before I even try this one, what do we know about profit? What is profit? Revenue minus cost. Okay. What was the rate of change for revenue? $3,000. What was the rate of change of cost? $1,000. What's the rate of change of profit? $2,000. Done. Ta-da! You like that one, don't you? Okay. But again, if we know the rate of change of revenue and we know the rate of change of cost, profit is just revenue minus cost. Same thing for rate of changes. So at 2,000, at 2,000 flash drives, the rate of change of profit is $2,000 per week. So I'll write that sentence. At 2,000 flash drives, the profit is increasing $2,000 per week. Okay, and with that, we are done with related rates.